how you doing? Welcome to today's lesson. We're going to be looking at inequalities. Right. So inequalities. Before we actually get on to solving linear inequalities, let's just look at what inequalities mean. Inequalities. Inex. Okay. I'm lazy. I have shorthand. Yeah. Okay. So let's look at a couple of things. The first one is less than. Right. Less than. Now, a lot of people stress about, I have to learn that if it faces this way, it's less than, and if it faces the other way, it's greater than. Don't. Just learn how to read it into a sentence, because you're never going to be seeing this by itself. You're going to always be seeing this in a mathematical sentence. So take a look at this example, e.g., 3 is less than 5. I just read it from left to right. I know that's an inequality. I know that 3 is less than 5, so I just read it, 3 is less than 5. And if you got greater than, okay? If you got greater than, so what? 5 is greater than 3. All I'm doing is reading from left to right, okay? So don't get hung up on, this means that and this means that. It doesn't. Just read from left to right. This is an inequality sign. It means it's not equal. Inequality, okay? Equality, inequality, not equal. Right. So 3 is not equal to 5. It's in less than. It's showing what it is in relation to 5. Vice versa, showing what 5 is in relation to 3. Now the only, new ones, if you want to call it that, but you've probably seen these two, are less than or equal to or greater than or equal to. Okay, so what? That doesn't mean anything. It just means that I can add on to this. We've got 4 is less than or equal to n, which is less than 7. Okay, well what does this mean? This means n is between 4 and 7. It can be any number between 4 and 7 if you're talking about a continuous spectrum. So if you're talking about temperature between 4 degrees and 7 degrees, it can be absolutely anything. 4.1, 4.5, 4.9, 5.3, 5.327, 568, whatever. You know, it doesn't make a difference. But let's just stick to discrete numbers, so whole numbers. If I'm talking about what are the possible values for n, then I've got n could possibly be, well, it can be 4 because it can be equal to 4. Right, can't be 3.9. But it can be 4. It can be 5, it can be 6, it cannot be 7. It can be 6.99999 until you run out of ink or until you drop dead, but it cannot be 7. Are you with me? This keeps it between 4 and 7. You're going to be using this a lot in statistics when you're talking about group sizes, okay, and modal classes and class sizes, etc., all that jazz. Okay, so let's take a look now at solving linear inequalities. Linear means the highest power is 1. Okay? So don't worry about quadratic inequalities. That's for like year 12 when you start to look at solving quadratic inequalities. Maybe some year 11s will get there as well early. But let's look at solving linear inequalities. Solving linear inequalities in X. Right. So, all we have to do is this works exactly the same as solving equations, okay? Exactly the same, except for one small thing. And I'll do that one small thing as an extension. It's not on my notes. It should be, but it's not. Hey, I'm learning as well here. Okay, so e.g. Okay, 3x is less than 27. 3x is less than 27. Now, if you've seen my video on solving equations, okay, you'll know that all I'm going to do is I'm going to reverse the order of operations. I'm going to do bit mass backwards. And to get rid of something, I'm going to do the opposite to the other side. So opposite times by 3 is divided by 3. So 3x is less than 27. So x is less than 27 divided by 3. So x is less than 9. Done. Okay, that's it. So what could the possible values be? Well, the values of x, they could be 8. If I'm talking about whole numbers now. What are the possible whole number values? 8, 7, 6, 5, etc., until I decide to stop. Okay? Forever and ever. Everything less than 9. X is less than 9. Done. Okay. Let's look at a two-step equation. So let's look at a two-step equation. Let's do e.g. I'm going to swap colors just so I can see what I'm doing here. 5x plus 2. 5x plus 2 is greater than 22. Okay? So, reverse bit mass. I'm going to be doing bit mass backwards. Bit mass backwards to decide what to get rid of first, and then I'm going to be doing the opposite to the other side to actually get rid of it. OTOS, opposite to other side. Okay, that's how I like to do it. Okay, so 5x is greater than 22 minus 2. Opposite plus 2 is minus 2. Okay, So 5x is greater than 20. You don't need to put in all these steps when you get good at it. I'm just showing you my thinking right now. Okay? You can jump from there to there. I would definitely show that step. And you can jump straight to the answer. But I'm showing you my thinking. So now opposite times by 5 is divided by 5. X is greater than 20 divided by 5. X is greater than 4. Alright? So, super. What are the possible values for x? Possible values, x could be, well, it could be 3, no, it can't be 3. It could be 5, could be 6, could be 7, could be yada 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 until you run out of space. Okay? Could be anything bigger than 4. You with me? Okay, fantastic. So those are solving linear equations. Now, linear inequalities, okay? So there's an inequality, and you're just solving it. You're doing exactly the same as solving equations. Are you with me? Okay, now I want to go back onto the other board because there's 2 more things that I quickly want to show you that are important to know. It's just a format that we write things in. So let's take a look at an inequality and express it on a number line. Okay, so we've got -3 is less than or equal to x, which is less than 5. Okay, and they say express this on the number line. Super. I don't have a ruler, so I'm going to draw my number line freehand. You should use a ruler. Okay, so if I draw my number line, I got -4. Always start past where you need to go. -3, -2, -1, 0, 1, 2, 3, 4, 5, and past where I want to go is 6. Just so that you've got that there. And there's my number line, carries on forever that way, forever that way. So I want to illustrate where x is on this number line. Well, x is between 3 and 5. Okay, so x is between -3 and 5. So it's between -3, so I illustrate that there, and 5. So x could possibly be all of these options there, absolutely everything. Now there's only one thing you have to take a look at, that's a convention. That's the word I'm looking for, a convention for what we do. Whenever it can be equal to the number, then we colour in the dot. So x can be -3. Whenever it can go up to the number but not equal the number, then we leave the dot open. Are you with me? Okay? Or the circle open. Make sure you can see it's an open circle, don't just put a dot there. Alright, so this means that x can be -3 up to, but not including 5. So 4.99999, if I'm going really, really close to 5 there, right there on the edge, 4.9 recurring, that's not 5, that's pretty close to it. Okay, so I don't use 4.9 because I can't illustrate that, I use 5. Alright, let's take a look at illustrating that with solving. Alright, so, last example, e.g., 2x minus 6, 2x minus 6 is greater than 2. Right? Opposite of minus 6 is plus 6, 2 plus 6 is 8. 2 plus 6 is 8, so 2x is greater than 8. See how I'm skipping out a step? Opposite times by 2 divided by 2, 8 divided by 2 is greater than 4. Okay. There's one small thing that I'm going to do as an extra in a second. I'm going to use this one to show you. Alright. And it's just a small thing you must remember when you're doing inequalities. Alright. So, x is greater than 4. Well, let's start at 0, 1, 2, 3, 4, 5, 6, 7. That's enough. Alrighty. And x is greater than 4. Well, that means at 4, I've got a dot, not coloured in because it can't be equal to 4, and it's everything greater. And I'll put an arrow to show that it's going that way. You with me? Please use a ruler when you do this. I don't have a ruler, so I've got an excuse. You're sitting in a book, you've got a ruler. Alright. Let me just quickly show you something that I just want to add on to this. It's not on my notes, but it's one small thing that you have to just worry about with you working with inequalities. If I've got this, minus 2x minus 6 is greater than 2. The only thing you have to remember, this is extra to my notes, and I'll probably put it on a little bit later as I get around to it, is when I divide by a negative, the only thing you have to remember is the inequality flips. So let me just do this. Minus 2x is greater than 2 plus 6 is 8. You with me? Now here's the thing. X, when I divide by a negative, I flip the inequality. That's all you have to remember. 8 divided by negative 2. Okay? So then x is less than 8 divided by negative 2 is negative 4. Okay, trust me with that. If you want to look for the reasoning, I'm sure you can find the reasoning somewhere. I'm probably going to put it on a later note as I get around to it. But the only thing you must remember is when you divide by negative, or times by negative I should say as well, you have to flip the inequality. Okay, well I hope that makes sense. Alrighty, take a look at more videos on the video side of the channel. Oh, I'm at a loss for words today. More notes in my blog. Okay, thanks a lot. Remember, I'm here for you.